Do you ever get to the end of a week and look back in astonishment to see all you've gotten done? I mean, I guess that can go both ways, but this week was the positive version. I mentioned in my last video that I'd be spending this week on the construction of a new biolab, and true to my word, that's exactly what I did. Well, it's not quite done yet. We made enormous progress, which I want to briefly take you through here. Once it's done, I'll be making a video going through the entire build process and how to stock a lab like this with all the materials and equipment needed to do some amazing biology work. However, since I spent most of my time working on this, I thought I'd take this week to give some updates and do a grab bag video while we finish off the build and some projects we've had in the works for a while. But first up, let's go over all the biolab stuff. It's being built in FooLab, and that meant reorganizing the entire space to accommodate the new room. The museum, full of all sorts of old computers and electronics, was sorted, organized, and relocated so that the shelves could be removed. Now, never let it be said that hackers are good carpenters. I am full of holes from trying to remove these, as there was screws and nonsense sticking out everywhere. Though I did get to do my best Jerry impression. My name is Mr. Crowbar, and this is my friend. That's also a crowbar. After that, we cleared the rest of the area, relocated the 3D printers, and made space for the new build. One trip to the hardware store later, and we were ready to start construction. The basic design is a wooden frame, which will have 2 layers of plastic covering both the inside and outside surfaces. Any staples used to hold the plastic on were sealed with construction tape, as were any edges. The reason we're going to such lengths is because this will be a positive pressure room fed via HEPA filtered air. While this may be overkill, especially for bacteria and yeast work, it will do wonders to keep the copious amount of dust that's in the rest of the hackerspace out of the lab. After we'd put up the plastic on the 2 outer surfaces that would be inaccessible once the room was in place and the top layer of the roof, the whole build was pushed into its final resting place and bolted to the floor and anchored to the back wall. Then we had to do something about the floor to make sure that all this work wasn't wasted by stuff coming up through the old wood. So everything was sealed with a thick layer of epoxy. With that applied, we covered the remaining walls with plastic to let everything cure and stay relatively dust-free so we get a nice finish. I'm partially thinking of painting a mural on this before we install all the equipment, just for that extra layer of awesome. Maybe a giant tardigrade or something floral? I don't know, we'll see. But for now, that's where the build is. Every day, more and more equipment arrives in the mail, so I'm super excited for this to be done so we can start filling it up. Next week, we'll finish putting up the plastic and then work on the air system and entryway, which we have a plan for to make sure it seals nicely. Really, the point of putting in all this effort now is to make sure that if we ever want to step up to something like mammalian work, we can build an airlock and do so without much effort. But it'll be a long time before we consider that. But one of the other benefits of a space like this is that it'll be perfect for things like laser experiments as well, because it'll be able to keep things nice and clean. Speaking of which, the new laser hardware has started to arrive, and I'm now the proud owner of a 2.5 watt 445nm and a 1 watt 850nm laser to play with, as well as some dichroic mirrors. I'm still waiting on the lenses though. If these aren't enough for second harmonic and at least some other nonlinear effects, I'm not sure what will be. Speaking of exciting packages that arrived, there's a few more that I want to talk about, though I'll save my favorite for the end of the video. When we talked about Go's last, I mentioned that I was waiting for Newelect to put out their new filter amplifier combo that was tuned for Go's reception. Well, it just arrived, so of course we were anxious to give it a test drive. During our downtime between parts of the lab build, we rigged up a new quick stationary mount for the antenna that we use for Pipsqueak's face. After setting it up outside and connecting it up to my HackRF, it took a little bit of fiddling to get the antenna pointed right, but sure enough, clear as day and perfectly centered on the proper frequency, the Go signal started coming in loud and clear. However, since the program we're working with to try and take those signals and turn them into the beautiful images we've been chasing doesn't work with a HackRF, we switched SDRs and wired in my Newelect Nestor Smart. And there wasn't a single thing to see. Conspicuously, the light that indicated the amplifier is being powered turned off immediately as soon as we wired in the Nestor Smart. To put it lightly, that was super weird. After a bit of tinkering, we found out a few things. The first is that the Nestor Smart is supposed to come with an always-on bias tee. Basically, this means that it's always feeding power out of the main SMA connector, so in theory, you can use it to power things like this. But for whatever reason, mine must be defective because I've never been able to successfully power anything via the bias tee. And something about the wiring was screwing with the amplifier, so as soon as it touched the SDR, the light turned off. We reasoned that if we could just disable the bias tee and power the amp externally like we did for the HackRF, it should just work. But since the bias tee is controlled by a wired connection, this meant opening it up. Yeah, this was not as simple as we hoped, as everything was encased in this horrible silicon foam and held on by the world's goopiest adhesive. After peeling it all off and spending 20 minutes cleaning all the gunk off with some alcohol and a Q-tip, the board was exposed and we could start poking around to see how to disable the bias tee. After comparing the circuit to some pictures of other SDRs online, we found the spot where we thought the bias tee was getting power from. We decided to take the risk, so using a heat gun for refilling PCBs, we removed that component. After a quick test to make sure the thing still worked, we were now able to power the amplifier properly, and the SDR could still receive signals. So for those of you who'd like to do the same mod, this is the component you need to remove to kill the bias T. But even after the mod, no dice on the signal. We since ordered another RTL SDR, so hopefully we'll be able to get that one working, though I suspect in either case it's just that we need to add a second LNA to get sufficient signal coming through, as one of the benefits of a hack RF is the built-in LNA, which seemed vital to getting the signal to show up even with the Sawbird filter. But if nothing else, we know that we can successfully receive Go's signals, so now it's just a matter of time till we can make some combination of hardware and software work together and produce some images. So be sure to keep an eye out for that in the near future. Speaking of radio, another fun package that arrived was sent by the Twitter user iHagster. They sent me a pair of their palm tree Vivaldi antennas to play with, and I'm super excited to experiment with them and already have a bunch of plans for these. They come with these awesome 3D printed mounts, which I really appreciated, and they even printed the frequency response of the antenna directly on them, so I didn't even need to look things up. The best part of these is the ridiculously broad spectrum sensitivity. The listing on their store, which by the way I've linked in the description, and chart printed on the antenna says that they work for anything between 1200 and 6000 MHz, and provide pretty good gain. They're also reasonably directional, which is nice. I'm thinking of mounting them on Pipsqueak as a way to massively boost the frequency range that the setup will work for, but thanks to their directionality, we're also thinking of maybe building them into a radar system, though we're not sure if we're going to start with active or passive radar. I'm currently studying for my ham license, so I might start with passive first. In either case, be sure to keep an eye out for these in the future, and I look super forward to testing them out. Finally, my favorite piece of mail, one that I've been waiting for 8 years. My silver play button finally arrived. First off, I want to again say thanks a million for all the support these last few years. I've had an absolute blast, and I'm chomping at the bit excited to get back to the lab and keep making more open source science for and with all of you. If the next few years are anything like these past few, I can't even imagine all the amazing stuff in store. And of course, I need to say a huge thank you to my amazing patrons who've helped put my mind at ease and allowed me to focus all of my attention on this work and making new content. Soon I'll also be joining YouTube's new membership program, but I'm still working on the badges and icons and stuff. So for those interested in supporting here rather than on Patreon, that'll be an option soon as well. And lastly, before you ask, no, I won't be cutting into this award. I've been waiting far too long to risk wrecking it. No, instead I'll be shooting it full of lasers, of course, but that'll be a topic for a future video. So be sure to ring that bell to see when the new videos come out, and I'll see you next week.